In this video, we're looking at topic 6 from the CFE review, which is arithmetic and geometric sequences. We're going to start with question 16, which says we have a school auditorium with a total of 21 rows of seats. It has 20 seats in the second row. It's important to note here that this is talking about the second row. 23 seats in the third row, 26 seats in the fourth row, and so on. So we're going to start by writing an explicit formula for this arithmetic sequence. Now, the formula that I taught you guys to use, a sub n is dn plus a sub 0. That's one that you will have to memorize, but if you can't remember that, they will give you a formula on the reference sheet for this test, and it's very similar, it just hasn't been simplified. It's a sub 1 plus n minus 1 times d. So either one of these is totally acceptable to use when you write an explicit formula. I'm going to go ahead and use the second formula here because it's the one given to you on the reference sheet, but it does simplify to the exact same thing as the first formula, dn plus a sub 0. So let's go ahead and take a look at the explicit formula here. So a sub n, that will tell me the value of any term. In order to do this, I'm going to need the first term from the sequence, a sub 1, but if we take a look at what they've given us, the first term should be the number of seats in the first row. They haven't given us any information about the first row. They've given us the second, the third, and the fourth. So I can use the information about the second, third, and fourth in order to find the pattern so that I can go backward to find how many are in the first row. So to get from 20 to 23, I've added 3. And to get from 23 to 26, I've added 3 again. So I know my pattern is plus 3, which means if I want to go backward to find the first row, all I have to do is subtract 3. So to go backward to the first row, I have to subtract 3, so I'll get 17 for my first row. So 17. Then we add to that n minus 1. I don't know what n is. We're not asking about a specific row here. Times the common difference. And the common difference we just discovered is the number positive 3. We add 3 every time, so times 3. Now, if you had done this using the original formula, dn plus a sub 0, you can see the common difference is the number 3, and we would have to add a sub 0, which is the 0 row. We would have to go backward one more time from the 17 and use the number 14. That would be the equation we could use from the first equation, and it's completely acceptable. Both of these are entirely equivalent. They mean the exact same thing. So we have our formula written for part A. Let's take a look at part B. How many seats does it have in the 18th row? In order to find the number of seats in the 18th row, all I have to do is plug in 18 for n. So a sub 18. I get 17 plus 18 minus 1 times 3. That's it. So 17 plus 17 times 3, and if we put that in the calculator, we get 68. If you use this other equation, it would work exactly the same. 3 times 18 plus 14 still gives you the number 68. Either way, you get the same answer. All right, let's take a look at question 17. Abraham just accepted a new job at a consulting firm. It's paying him $47,500 during the first year, and an annual increase of 7% beginning in the second year. It's asking what he can expect to earn in his 5th year with the firm, and we want to round to the nearest dollar, so we want a whole number here. Now, this is a 7% increase every year. To find a percent, I have to use multiplication. So since I'm multiplying by a number every single year, we're going to call this a geometric sequence. So the formula that's going to be given to you for a geometric sequence is a sub n is a sub 1 times r to the n minus 1 power. And I want to fill in the terms that I can here. So to find the 5th year, we're going to be using n equals 5. The first term is the originating term, so the original whatever. And since we're talking about a salary, money, the originating money is his initial salary, which is $47,500. Now, the trickiest part about this problem is finding R. R is the rate at which his money is increasing. Now it does tell us that it's 7%, so we're going to use that as a decimal, which is 0.07. The problem is, if I multiply 47,500 by 0.07, my answer gets smaller. It just finds 7% of the original. It tells me what his raise will be, but it doesn't tell me what his new salary will be, including that raise. So in order to find what the rate is, I have to take into account that this raise is getting added to his original salary. And this rate is given as a percent. So I have to take the increase of 7% plus the amount of his original salary as a percent. Now his original salary is 100% of the money he makes. So I have to add it to the number 1. So his actual rate is going to be 1.07. If I use this as my rate instead, what it's going to do is it's going to take the increase and the original and add them together to tell me his new salary instead of just telling me the increase. So let's go ahead and plug these values into my equation. So we're going to have ace of 5, and we're going to take my first term, 47,500. We're going to multiply it by the rate, which we just discovered is 1.07. And we're going to raise that to the n minus 1 power, so the 5 minus 1. When we plug this into the calculator, our final answer is going to be the amount of money he'll be making in his 5th year, ace of 5, which is 62,262.81. So we're going to round that to the nearest dollar, which is $263. So $62,263, not bad for 5 years. All right, we have one more problem to look at for this topic. This problem is giving us a recursive formula and asking us to write the same formula in explicit form. So a recursive formula, remember, uses the previous term, and this is what tells us that. We know that ace of 1 means the first term. We know that ace of n means any term. So if I'm looking at the term ace of n minus 1, that means any term minus 1. So backward one step from any term, so the previous term. So ace of n is the previous term minus pi. That means every time I move forward in my sequence, I'm subtracting pi every time. The way we read that is that this minus pi, it's being subtracted. That makes this arithmetic. There we go. And that minus pi is our common difference. Every step I move forward, I'm subtracting pi. So d is minus pi. Now all we have to do is throw in the information we know from this problem into this arithmetic formula, which again is the one that they give to you as a reference. We need d, which we just discovered is negative pi. We also need ace of 1, which with the recursive formula they always have to tell you. And I know that this formula is, this word problem is written a little awkwardly. It says the first term is, and then the 7's all the way over here. But it still tells us that ace of 1 is the number 7, which means I'm ready to plug them into this formula. Ace of n is going to be the first term, 7, plus n minus 1 times the common difference, and the common difference is negative pi. And that's it. We're all done. We found our final formula. All right, we're going to pick up with topic 7 in the next video.